China has quietly become the most active nation in lunar history, and almost nobody is talking about what they are actually building up there. By the end of this video, you will understand the full plan, why it matters more than any space race in history, and what it means for every human alive today. Most space programs work in bursts. A big announcement, a dramatic launch, a few years of silence, then maybe another mission if the budget survives. China did not do that. Starting in the early 2000s, they sat down and drew a roadmap that would unfold over multiple decades, where every single mission was designed to feed the next one. No wasted launches, no redundant experiments, just a steady, deliberate climb towards something enormous. The plan broke down into 4 distinct phases. First, orbit the moon and study it from above. Second, land on it. Third, bring pieces of it back to Earth. And fourth, stay. Not visit, stay. Each phase had to be completed successfully before the next one could begin. Think of it like assembling a machine where every component depends on the one before it. Skip a step and the whole thing falls apart. The first spacecraft, Chang'e 1, launched in 2007 and spent over a year circling the moon, producing some of the most detailed surface maps ever created at that time. No landing drama, no headlines, just clean, usable data. Chang'e 2 followed 3 years later and sharpened those maps even further, down to the level where engineers could identify the safest possible landing zones. These missions were not glamorous, they did not go viral, but they were doing something absolutely critical. They were building the blueprint that every mission afterward would depend on. In 2013, Chang'e 3 became the first spacecraft to soft land on the moon since the 1970s. Nearly 4 decades had passed without a single landing anywhere on the lunar surface. And then China did it, quietly and precisely. The rover that came with it, Yutu, meaning Jade Rabbit, rolled out onto the gray, dusty surface and immediately got to work. Within days, it found something that stopped scientists cold. The rocks were different, not slightly different, fundamentally different from anything the Apollo missions had ever brought back to Earth. For decades, everything humanity knew about moon rocks came from 12 astronauts who had all landed in roughly the same region. Scientists had studied those same samples for generations, all built entire models around them, written textbooks based on their composition. That picture, it turned out, was wildly incomplete. Yutu's instruments identified a type of volcanic rock with a completely different chemical fingerprint, minerals arranged in a way no one had cataloged before. It was like reading an entire cookbook cover to cover, memorizing every recipe, and then finding out someone had hidden a completely different cuisine in the back pages the whole time. What this revealed was profound. The moon is not a simple, uniform rock. It is geologically complex, shaped by processes that varied dramatically across its surface and across billions of years of history. The areas Apollo had explored were a small cluster of dots on a map that stretched millions of square miles in every direction. If even the familiar areas were hiding surprises, what was waiting in the places no mission had ever reached? If you are finding this fascinating, hit that like button right now and drop a comment below. Would you trust China to build the first permanent human base on the moon, or does that make you nervous? And subscribe so you do not miss the next video, because this story is accelerating fast. The far side of the moon has never once been visible from Earth. Not with the naked eye, not with any telescope ever built. The moon rotates at exactly the right speed to keep one face permanently pointed toward us and the other permanently pointed away into deep space. Landing there had always been considered nearly impossible. The moment a spacecraft touches down on the far side, it loses all contact with Earth. No signals in, no signals out, no way to know if anything is going wrong. China solved this with elegant precision. Before sending any lander, they launched a small relay satellite and parked it in a specific orbit where it could see both the Earth and the far side simultaneously. Signals could now bounce back and forth between the lander and ground control like a trusted messenger running between 2 rooms with no connecting door. In 2019, Chang'e 4 landed inside the South Pole Aitken Basin, one of the largest and deepest impact craters in the entire solar system, stretching more than 2,500 kilometers across, roughly the size of Western Europe. Scientists believe it may have punched so deep it exposed material from inside the moon's interior, rock that has been buried since the very beginning of lunar history. Then in 2024, Chang'e 6 did something nobody had ever attempted before. It landed on the far side, scooped up approximately 2 kilograms of ancient soil, sealed it into a container, fired a small rocket off the lunar surface, docked with a waiting spacecraft in orbit, transferred the samples, and flew them all the way back to Earth. Every single one of those steps had to work flawlessly. None had ever been tried from the far side before. The rocks that came back were 2.8 billion years old and showed evidence of volcanic activity far later than anyone had predicted. The moon's geological story ran longer and stranger than any textbook had captured. But as extraordinary as all of that was, it still is not the main event. Picture the very bottom of the moon, the South Pole. Because the moon barely tilts on its axis, sunlight hits the poles at an extremely shallow angle. Some craters near the South Pole are so deep that their walls block out every single ray of sunlight completely. Not for a season, not for a millennium. Some of these craters have sat in total, unbroken darkness for more than 1 billion years. The temperature inside those craters drops to around -200 degrees Celsius. That is colder than the surface of Pluto and among the coldest natural environments found anywhere in the solar system. And sitting inside that cold, frozen darkness, scientists believe, is water ice. Over billions of years, comets and asteroids slammed into the moon carrying water. Most of it evaporated and drifted off into space, but in those permanently shadowed craters, there was nowhere for the water to go. It simply stayed, frozen solid, preserved like something left untouched in the back of a freezer for an unimaginable stretch of time. Now think about what water actually means in space. Water is made of hydrogen and oxygen. Oxygen is what astronauts breathe. Hydrogen is one of the most powerful rocket fuels ever developed. If you can mine that ice, split it apart, and convert it into breathable air and rocket propellant, then the moon stops being just a destination. It becomes a fueling station, a supply depot, a launch pad for everything beyond it. Earth's gravity makes getting anything into space extraordinarily expensive. The moon's gravity is only 1/6 of Earth's. Launching fuel from the moon into deep space would cost a fraction of the equivalent Earth launch. Missions heading to Mars, to the moons of Jupiter, or further out could stop at the moon, refuel, and continue onward. The moon becomes humanity's first off-planet supply hub, and whoever builds it first shapes the rules of space exploration for generations. To confirm those water deposits, you cannot just orbit overhead and guess. You have to go inside those craters directly. Normal rovers run on solar panels. No sunlight means no power, and no rover built for standard terrain can handle the jagged, unpredictable floor of a crater that has sat undisturbed for 1 billion years. China's answer is Chang'e 7, planned for 2026. It carries something that has never been used in lunar exploration before, a small probe designed to hop. Instead of rolling across the surface, it leaps directly into permanently shadowed craters, carrying instruments that can detect water molecules, analyze hydrogen signatures, and measure frozen deposits embedded in the ground. It jumps in, does its work, and jumps back out of places that would destroy a conventional rover in minutes. The full mission pairs this hopping probe with an orbiter, a lander, and a surface rover, all 4 working together as one coordinated team. If Chang'e 7 returns with solid confirmation of large, accessible water ice deposits, it would rank among the most consequential discoveries in the history of space exploration. Not just scientifically significant, but practically world-changing. And that confirmation would immediately trigger the next phase. Chang'e 8, planned for around 2029, focused entirely on learning to build on the moon using only what the moon provides. Heating lunar soil into bricks, pulling oxygen from minerals, using robotic 3D printers to construct walls, the floors, and radiation shielding before any human crew ever sets foot there. If those technologies work in the actual lunar environment, you no longer need to ship construction materials from Earth. The moon helps build itself, all of it. The orbiters, the far side landings, the sample returns, the water hunt, the construction tests, feeds into one final objective: a permanent research station at the lunar South Pole with construction set to begin in the early 2030s. Robotic missions arrive first. Infrastructure gets built. Then humans follow, initially for days, then weeks, then months, then permanently. Dozens of nations have already expressed interest in joining this project. China's Long March 10 rocket completed a key test flight in early 2026. The cruise spacecraft passed a critical emergency abort test around the same time. The moon was never a finished story. Every mission China sends makes that clearer. It was always the introduction to fuel, to infrastructure, to a permanent human presence beyond Earth. And right now, piece by piece, the foundation is being laid. If this video shifted how you see what is happening on the moon, smash that like button and subscribe right now. We cover every major update as it breaks, and I want to hear from you in the comments. If a working moon base is operational by 2050, would you sign up to live there, even for just 6 months? Drop your answer below.